So we're moving to quadratic models. So yesterday we did the line of best fit for linear models. Today we're going to discover what happens when I have a quadratic model and how can I do that. So a quadratic model represents quantities that are non-linear. Which do not have a constant rate of change. Remember yesterday when we did the rate of change, when we did the y2 minus y1, we found that the first difference was constant, right? And that means it's a linear function. With nonlinear functions, such as quadratic model, the rate of change is not constant. So with linear function, the first difference was constant. In a table of value for quadratic, what would be constant? The second difference. What do we call the curve of a quadratic function?
Slope.
A parabola.
A parabola.
So it's going to look like this, right? Or it's going to look like. Now, if you're looking at the equation has a degree of 2. And it's written in a form, if you're going to look at the standard form, it's going to be y equals ax squared plus bx plus c. Now, this also can be written in vertex form or can be written in factored form. They still indicate a quadratic function. But it's very important to understand that a in this case cannot equal to 0. Otherwise, if a is equal to 0, we'll end up with a linear function, right? So that's why we specify that a cannot equal to 0. So if I have a table of values, if I have a table of values and I want to know if it's linear or quadratic, all what I have to do is the first and second difference, right? If the first difference is constant, I know it's linear. If the second difference is constant, I know it's quadratic. If I have a graph, depends on the shape. If it's a parabola shape, it's quadratic. If it's linear, if it's a straight line, it's a linear. And then if I look at the equation, depending on the degree, I can decide if it's linear or quadratic. So looking at this one here, it's a table of values. So what must I do?
238 minus 250.
So I have to do the first difference first. So I try the first difference. So I subtract y2 minus y1. And that's going to be minus 12. And then I do 202 minus 238. So that's going to be minus 36. 142 minus 202, that's going to be minus 60. So that is clear that my first difference is not constant. So I have to test now the second difference. When I test the second difference, I do the same thing, but I do the first difference minus the second difference. Sorry, that's not true what I just said. So I do So I have to do this minus this. So negative 36 minus negative 12, so that's negative 24. And then minus 60 minus negative 36, that's again negative 24. So what do you notice with the second difference?
It's constant.
It's constant, so because of that, then I'm going to say that it's a quadratic function. So second difference is constant. Therefore, it is quadratic. So I have the second example where I have another table of values. So if I do my first difference, that's the only way, using a table of value, that's the only way to figure out if it's quadratic or linear, unless you graph it. But also don't forget that we need to look at the x values and make sure that they're going up by the same value, right? So if you look at the x value, they're going up by 1, so that's perfect. I can do my first difference. So by doing the first difference, so that's 48 minus 32, so that gives me 16. 72 minus 48, so that gives me 24. And then 108 minus 72, that gives me 36. So again, this is another example where the first difference is not constant. So I know it's not linear. I have to try the second. So if I try the second difference, which is 24 minus 16, that gives you 8. And then 36 minus 24, that gives you 12. So in this case, neither the first nor the second are constant, so therefore it's not quadratic nor linear. The question is asking me which model represents quadratic relation. So in this case, it is not a quadratic relation. Because the second difference is not constant. If I look at the graphs in this case, I have graphs. What can you tell me about the first graph? Quadratic, because it's a parabola. So the function is quadratic, and it's a parabola shape. How about the second one?
Linear.
Linear, so it's not quadratic. It's linear. Okay? What can you tell me about y equals x squared plus 7?
That's
Quadratic, why?
because it's a degree of 2.
And f is quadratic or not?
No.
Not. What is it?
Linear. It's a degree of 1.
That's true.